Hey guys, how's it going? All right. Let's start talking about blood. Now, we've already covered circulation of blood through your body using the different blood vessels in the heart. Now, let's talk about blood and what it's made of. So, let's start by labeling everything. So, erythrocytes are your red blood cells. Sites. Then we have our leukocytes, which are white blood cells. They are here. Leukocytes. And one thing you got to understand is site actually means cell. So anytime you see anything ending with site or cyto or anything like that, it means cell. So leukocyte is a white blood cell. Leuko means white, erythro, red. So red blood cells, white blood cells. Then we have platelets. Here are the platelets right here. These little yellow things. Platelets. And we have our plasma here. This is just a little blood vessel here, so don't worry about that. Now, erythrocytes are really interesting because they are the oxygen carrying part of your blood. So without erythrocytes, you don't live. And that part of the blood that carries oxygen is hemoglobin. It's just a protein that carries oxygen, so make sure you get that in your vocab. Also, it has Rh factor around the outside of it. And what Rh factor does is it's just a protein that's found on the outside of erythrocytes. Either you have it or you don't. You inherit it from your parents. So let's say I test positive for Rh factor, and my wife tests negative for Rh factor. Now, when we have kids, you have to take that into consideration because the baby might be positive for Rh factor, which means my wife's body might actually fight it. It might actually fight the baby. Not at first, not with the first pregnancy, because it won't really recognize it, but after that, it will. With the second pregnancy, it might actually fight off the baby, might have miscarriage. And so now we've discovered that there's a shot we can give the mom if she is negative that will help her so she doesn't fight off the baby that's inside of her, because she recognizes it as foreign because she doesn't have the positive, but the baby does, and their blood kind of mixes a little bit. And so, yeah, your body's probably going to fight that. Now, let's talk about leukocytes. Leukocytes are white blood cells. That's these bad boys right here. Okay, they are your disease fighters. They're going to fight disease. So what happens is they put out all these little antibodies for different things that are in your body that are foreign. So anything that's foreign, there's an antibody for it. Or if you get the disease and it's not foreign, then your body builds up antibodies for it. So like you get a tetanus shot so that your body can recognize what tetanus is like, and it will actually fight the tetanus before it takes over your body because it has antibodies to do that. And so the white blood cells can eat it before it takes over. Anything is like that. So right now, coronavirus is pretty big, and we don't really have any antibodies for it. So it's hard to fight off something you don't know what it is. So that's what they're trying to make a vaccine for. Now, platelets are also called thrombocytes. Thrombocytes. Put a B in there. There we go. Thrombocytes. Thrombocytes actually clot the blood. So anytime you get a cut and it just stops bleeding, that's your platelets, thrombocytes. Now they use a protein called fibrinogen that makes fibrin, which clots your blood. So fibrinogen is a protein that helps make fibrin, and fibrin is what clots the blood and makes it stick together. So pretty cool. And plasma is the last one. It's all this clear liquid running through here. Now plasma gets we're going to say donated. I like to say you sell it because you get paid to donate your plasma. But anyway, that's not the point. Anyway, plasma, it's going to carry everything in your blood, like your proteins, carbs, fats, anything like that. Water, all kinds of things are in your plasma. So if you don't drink a lot of water, your plasma is going to be really thick and you're just going to have too much concentration in your plasma. So you need to drink water so your plasma actually has a good fluidity so that your blood can get around to where it needs to go. Also, it's going to carry around a bunch of your waste, like your carbon dioxide, in the form of acid and things like that, so that you can get rid of stuff out of your body. So it'll travel through your kidneys, water will get pulled out of your plasma, a bunch of the waste, so you can get rid of the stuff you don't need. All right, and that's your blood for you. Next, let's move on to the next time. Okay, now we can move this out of the way. All right, now, blood types. Blood types are very important, and we didn't discover them till later on, and so lots of people kind of, didn't do so well when they got a blood transfusion. So, what the different types we have are, you have type A, type B, type AB, and type O. Now, let's look at this table and kind of understand it a little bit. So, your red blood cell has different antigens on it. If you have type A blood, you have the A antigen right here, which means your body is going to recognize A blood and say that it's not foreign, it's native. But you are going to have an antibody to fight off B. You're going to have the antibodies to fight off B blood. So if you get B blood in a transfusion, your body will fight it and you'll get really sick. Same thing with B. If you have type B blood, you have the B antigen, so you will recognize it and you'll have the antibody for A blood. So your body will reject A blood. Now, if you have AB blood, you can receive blood from pretty much anybody because you do not have antibodies to fight it off and you recognize both of them. I love these pictures here because they're very good at kind of demonstrating what's happening. Now, O blood, they are kind of the universal donors. O negative is the universal donor, but O positive can donate to anybody that has the Rh factor. So you're also going to have an Rh factor antigen on here as well. If you have Rh factor, if you don't, it's not present, and so you can't get that type of blood. So type O blood, they have antibodies for both A and B, so they can only receive O. I like to call them the selfless blood types, and they don't have any antigens. So you can donate to anybody because it's not going to really mess up anything. All right. Now let's look at this. This is kind of fun to look at. I like this chart. It just kind of shows what type of blood people have percentage-wise. All right, this graph shows approximate worldwide distributions of different blood types. Note that the different locations and ethnicities differ. Figures vary from those shown in this distribution. So A positive, right, that means they have the Rh factor, 31%. A negative is 2.5%. So that's really rare, right? Then B negative, 1%, B positive, 15, right? O positive, 42. And a B positive, AB negative is the most rare blood type in the world. Most rare blood type in the world is AB negative at 0.5%. So they can receive from anybody. Let's just talk about this for a minute. Negatives have to receive from negatives. So if you don't have RH factor, you have to receive. Now notice the percentages of the people that are negative. So they're going to have a harder time finding blood. Now, O negative can donate to anybody. Oh, but they can only receive O negative blood. Luckily, there's only 3% of the population that's O negative. But O positive can donate to anybody with a positive. And so that's very good that 42% of the population is that. Oh, thank goodness. Okay, but blood typing is really interesting. Now, let's go back to the last slide. I forgot to cover that vocab word. Now, how we test for these antigens is it's called a process of agglutination. That's in your vocab right there at the bottom left of the screen. And it's just a clumping of the antigen and the antibodies. So when you have the antigen and then you put in type A blood, you have the antigen for A, nothing's going to happen. But if you throw in the antigen for B into the blood, boop, it's going to clump together and coagulate, kind of what we call it. That's called agglutination. So it just comes together and kind of sticks together and looks all stringy and stuff. So that way we know that, hey, they actually have type A blood because we threw A in there and nothing happened. And so you're good to go. All right. With O, you would actually have, if you put type A blood in both, if you put antigen A and B in there, it would coagulate for both. And they do the same thing for RH factor. You just put the antigen for RH factor in there and see if it agglutinates or not. All right, so let's move on. Nope, I want to stay there. Now, our next learning goal is explain the different, oh, well, we already did that. All right, let's talk a little bit about blood pressure. Now, blood pressure, you have systolic and diastolic. Systolic is the pressure as your ventricles contract. So if we're looking at this, it's as they're contracting. So that's this one. As it's pumping, how much pressure is there? And then as it's relaxing, that's diastole, how much pressure is there? As blood's coming into the ventricles, how much pressure is there? So a good solid blood pressure is 120 over 80, usually. Anywhere 140 to over 60, that's just fine. Anywhere within that range is good. So yeah, that's just kind of what's happening with blood pressure. Pretty interesting. And heart disease. Oh man, there are a lot of different heart diseases, but first, let's just talk about the main ones that we hear about. You have cardiac arrest or myocardial infarction. That's a heart attack, so the heart just seizes up. It just stops working. Congestive heart failure. Oh, well, let's talk about some symptoms for cardiac arrest. So, symptom, you're going to feel it on your left side. And the reason for that is right off your aorta, you have an artery that runs straight to your arm. Your right side, you don't have that. It kind of gets filtered by an artery splitting into two, but right off your aorta, you get the left artery coming off. It's called the subclavian artery, and it is going to kind of put a lot of pressure in there because it's constantly contracting. So your left arm's going to really hurt. You feel a lot of pain in your chest, things like that. Now, congestive heart failure is the chronic condition in which the heart doesn't pump blood as well as it should. So your heart's just failing and it just isn't working like it should. Arrhythmia is the improper beating of the heart, whether it's too fast or too slow. And we've heard this word a lot. At least I do. I hear arrhythmia a lot. Oh, I have an arrhythmia. My heart doesn't beat properly. So those are some of the things that we hear about. Also, we hear about different things like plaque in your arteries or getting a triple bypass. Right? We talked about that earlier. So Yeah, those are the different types of heart disease.